Hello viewers! In this video, I'll go over the questions in exercise 1J on infinite geometric series. Here in the first question, we want to find out if the sum below are going to be converging, meaning if they are going to be between -1 and 1 for the common ratio, and if so, then we will find that sum. So in the first question, the common ratio is times 1.5. You can simply just take a ladder term and divide it by the former to find that ratio. And since this falls outside of the ratio restriction, therefore this will not converge. So you will say not converges. We can also say this diverges. And we will just continue then on. Here we have fractions. So if I take the ratio of the top and bottom, and also noticing that this goes from negative to positive, so therefore I will have a negative for our ratio. This is a alternating series with ratios 3/4, negative 3/4. So this is between -1 and 1. So if I draw another line, negative 3/4 will be somewhere near here. So we're good to go. Then we can go ahead and just write down the infinite sums formula, which is the first term over 1 minus the ratio. And we can just plug that into the calculator. Oh, maybe I should show you how to do so without one. So we have this there, which is really the same as 7/4. Now if I do this kind of neat trick in multiplying the bottom by 2/2, we will have the fraction with the same denominator. Then we can just strip out what's on the top for each of the fractions and write them as a ratio. So it works actually quite nicely. However, I think I forgot to I forgot to multiply this by 2. Sorry. So this should be 14/8. You can confirm this answer by actually doing fraction division and also just do keep change flip to change the division to multiplication. And there we have the sum. Okay, see. Now technically, this is already the sequence formula. This is actually U1, and this is actually R. But let's just expand a few terms out and see what it looks like. So we replace n with 1. We replace n with 2. And let's just do one more. So this will be the same as -5/2. This would be -5/4, because 1/2 all squared becomes 1/4. And then you should see that there is a pattern emerging. This will be -5/8. So what do you notice? This is always going to be times 2 on the bottom. And it's always times 1 on the top. So if I write that as a ratio, then the ratio will just be 1/2, which is exactly what we have inside the bracket anyway. So that lies between -1 to 1, so therefore this will converge. So this converges, and I should actually write down plus ... to represent that this goes on forever and ever. Using our sum formula, we have the first term to be -5/2, all over 1 minus 1/2, which is -5/2 divided by 1/2 And look here, we have the same denominator. So this will just be negative 5 over 2 over 1. I can't read. Which is just minus 5. How nice. So if you recognize these sort of summation here, you can actually just extract the information for the common ratio right away. Be careful about the first term though, because we do have n starting at 1. If this question have a starting index at, let's say, 3, then that's no longer the case. The common ratio stays the same. However, this will actually start at negative 5 over 8. Okay. So now if we actually use the trick from what we just did before, or I mean using the analogy, then this is actually just r. But then what's going on here? Okay, what does this actually represent? Well, actually, we're going to expand our few terms and see what the pattern looks like. So we're going to replace n with 1, replace n with 2, and let's replace n with 3. Plus dot dot dot. So this infinite sum looks like this here. This little dot is a multiplication dot. And we have this here. Now, if I have negative 1 raised to an even power, this will become a positive. So as an aside, we have negative 1, not very interesting. Negative 1 times negative 1 is negative 1 all squared. And then you see that that's positive 1. And if I times it by 3 times, I mean 3 factors, this will stay negative. And if I repeat that pattern on, then you will recognize that for even powers, it will become positive. And for, so this is odd power, this technically this. And this even power, odd power, even power. So here we have all squared, so therefore negative 1 all squared becomes positive, positive 1. The next one becomes a negative 1, because it's odd power. Then we have a positive again. So if I combine these two signs, this is 2 minus 4 plus 8, and so forth. Next few terms will be minus 16 plus 32 minus 64 plus 128, and so forth. So because r, so if you look at this, this is r. R is actually negative 2, so not just 2 itself, but this is actually telling you what the sign is. So if it's alternating, combining with this here, this is where the minus comes from. But because this falls outside the ratio restriction, so this is not a converging sum, so it just diverges. Okay, what's going on here? Okay, this is technically, so if I take the second term and divide it by the first term, we can actually factor out the top and the bottom. And then we can actually simplify that. So this has a common ratio of 9 over 27, which can be written as 1/3. So that's our common ratio actually. You may actually see this firsthand. You're like, oh, it's just divided by 3 to each. Oh, what happened here? It's just divided by 3 to each term, right? So therefore, it's the same as multiplying 1/3. So you can also do it that way. And because r is between -1 and +1, then we have an infinite sum. So let's write down the first term, which is actually 2 terms. I mean, the first term is representing an expression with 2 terms. over 1 minus r. So this is dividing by 2/3. Now here, there isn't like a quick and easy way, so let's just do division, keep change flip. And then let's expand that out. So if I take 3/2 and expand to this here, these will both be 81 over 2, 81 over 2. Okay, immediately you recognize that this is just times 2. The bottom doesn't change, so you can pretty much just look at what's on the top. So again, this falls outside of the R restriction, so this diverges. And we move on. Nice. Another question with cert, but this time the doubling effect is happening on the denominator. So therefore, this will have a ratio of 1/2. It is within our restriction. So go ahead and write down the infinite sum. It's the first term divided by 1 minus the ratio. Is 1 over root 2 divided by 1/2. So we can write it as this here. Times, no, let's do divide 1/2. Keep change flip. So this will be 2 over root 2. For higher level students, you may actually need to standardize, rationalize this. So this becomes 2 root 2 over 2, which is just root 2. But for SL student, you can pretty much stop here. Okay. Excel students, depending on what the question says, they may actually want it in a particular form. So make sure you read the instructions. Okay, 2 and 3 are just fun examples where you just have to construct a series yourself. And if you're smart enough, you will just take one of the examples above and tell me which one converges, and then use that as an example, and which other ones doesn't. So give an example where it does have a finite sum. So if I just choose the ratio to be 1/2, and maybe I will just write down the first term to be 1, and then I will have this infinite series rather. So there you go. And then question 3 is, question 3 is also the same, except you want an impossible one. That means it diverges. So you just pick R to be anything that's outside of 1. You can do 2, you can do 4, you can do a million, you can do negative 1 billion, whatever. So again, I'm going to start off with 1. Just make it easy to calculate. Okay. No infinite sum. Because these numbers gets bigger and bigger and bigger and bigger and bigger, well, how big does it go? It goes as big as, well, there isn't the biggest number possible. So it just keeps on going and going and going and going, like the Energizer Bunny. Okay, now we have a dropping ball example. So if I were to draw the diagram, it might look like this. So first, it drops down by 12 feet. Then it bounces back up 3/5 of the previous height. Drops back down the entire way. And then 3/5 of the previous bounce drops back down. 3/5 of the previous bounce drops back down, and so forth. So here, I'm just going to write down the vertical distance on the curve. I mean, technically, it's supposed to be this. But then when it comes to labeling, it's not as smooth, right? It actually goes up. Yeah. So I'm just going to write down the vertical drops on the curve itself. I mean, it's just diagram to help us pace our thinking anyway. So first it goes down by 12. And then when it comes back up, 3/5 of 12, it's going to be 36 over 5. 36 over 5. 36 over 5 down. And then you multiply that by 3 over 5 again, which will be 108 over 25. And another 108.25 down. And so forth. So maybe I should write down one more here. This will be 3/24 over 125. 3/24 over 125. So your total height, sorry, your total distance traveled may look something like this. And then we're going to group them in a way that you can actually see what the infinite sum looks like. This should be 125. So I wrote this wrong. And so forth. So first of all, we can group this by saying this 2 times as much. And then we know that this has a common ratio of 3/5. That's pretty much the elasticity, right? And then we can go ahead and write down the sum formula. So this is an infinite sum with the first term being 36 over 5. So not 12, because the first sort of infinite series term occurs right after it bounces, right after it first hits the ground. So therefore, it's this part here. The first term is actually representing this part of the duration. And then we have 1 minus 3/5. So we can go ahead and, should we use a calculator or not? Okay, so let's challenge ourselves and not use one. Bottom will be 2/5. 36 over 5 divided by 2/5. And because they have the same denominator, I can just write it as 36 over 2, which is 18. Is this in meters? No, it's in feet. Usually it's in meters. So another way that was proposed was looking at the picture like this. If I were to add, should I copy this here? How can I do that? No, I'm just going to add onto the curve. So another way to look at, no. Oh no, the computer's going to go crazy. Copy, paste. So another way to look at this here is to actually complete sort of this picture here. It doesn't really make sense because the ball doesn't travel in negative time. But here we can actually use this and establish the symmetry. So the nice thing here is, well, now I sort of have like double of everything. So I could actually just do 12 plus 36 over 5 plus 108 over 25. And it just times this whole thing by 2, right? Because it's actually symmetric now. You have up and down, well, it's actually up and down for every loop. So if I were to do this, I need to actually take away what I added as part of the purple curve to balance it out. And then if you follow through this process here, this is that. So if you follow this through, the bracket represents the infinite sum with 12 being the first term now. And it will just deduct 12 at the very end. And that's 12 divided by 2/5 is the same as And this cancels, right? So you still get the same answer. So it doesn't matter which way you get, which way you do, you still have the same answer when it comes to infinite series. How nice. And lastly, we have this oil production rig. So oil is a finite resource, so you can't just have infinite. Well, I mean, in this case, you are looking for the infinite, which is not infinite because it's finite. It's a finite sum. It's an infinite series that leads to a finite sum. So on the first day, it produces 426 gallons, and it decreases by 0.1% each day. That means it will only retain 0.999 times as much as the previous day. So this is your common ratio. I don't even want to write this down because this is going to be a weird decimal. Can I just... I'm going to leave it in this form. Okay, because we already know what the common ratio is. So it's not really important what that figure is. So we're adding all these infinitely many times. So we can go ahead and crunch out the number. First term over 1 minus, this will be 0.001, which is the same as times it by 1000. If you don't trust me, this is what it looks like. Do you remember how to do decimal division? If not, you can always just write it back as a fraction and change it to keep change flip to multiplication and multiply. Okay. So that's the answer. But that's not what the answer key says. Oh, okay. No, this is correct. You lose 1% every, decreases by 0.1% each day. So that means you only have 99.9% of the previous day. Yeah. I don't know what's up with the answer key. The answer key seems to be like 1,000 times bigger. They are 42 times bigger. Oh, sorry. It's not looking for gallons. If there are 42 gallons in a barrel. So actually it's 426 this barrels. Oops. So be very careful with your units. I was actually not looking at it. So this is how many barrels you can produce, and each barrel is 42 gallons, so make sure you multiply by 42, unlike me. There. Okay, hope you guys learned something, and I'll see you in my next video.